Okay, good morning everybody. My name is Marco Bastigliano and today I will be your teacher of RPL, which is the Robot Programming Language of Robots. Let's start with material you may already have been provided. If I look at Robox and RPL, you may have the manual, okay? Okay, there is one manual. This one is provided on a shared folder on OneDrive with effort. So you should be allowed to get this document. And it was the same shared by Sonia or by Yuhao maybe in the group for the lesson of today. So this one is a 42 pages manual. You should read just even once to have an idea of what RPL is. Let me do a little introduction. So, according to programming, we think that it is better to have a language which is very easy, very high level inside the structure for the programming side, but for the user it should be very easy. Because we want to go to the customer to bring the robot, put the robot, just make the teach of some point, just download maybe some kind of app on the CPU and start working. So we make an easy installation, very fast, and the system is very easy also for the customer who is not a software developer, who is not a technician maybe, and so he may see and work with an easy system, and this will allow us to sell more, of course. This is the target, as always, okay? So, now I make you see what I do to make the system start from zero. We have nothing now. So, I take the flash here, and we have a predefined workspace. Okay, it is now, yes, a lot of stuff. We have a lot of things in here, but you do not worry so much. I make Ctrl X. Now, I take out the old stuff inside my fashion. Oh yes, I can make. Now I make the screen absolutely bigger. Otherwise, it will be very difficult. Yes, let's try maybe too much. 150. Yes. Okay. So, in here we have a lot of things, so don't take account, don't take... this one is just my one, so I set... Okay, this is mine, don't care about this. These folders are already created by the project which is called the GitLab. Now I open that project so you see. Okay, we have, what happened to my, as always, okay, my icons go elsewhere on the screen, you see, because of the Windows, very stupid Windows. Okay, now I open everything but not this, of course, open project. I have saved my copy of this one. Where the hell is this? No. No. Let me check 1 second. I know it's here. Yes. RPL. Okay, it's here. I go here. I have the GitLab. Okay. And I take this. Now the project, I have to move a little the screen. This project is already built and should be again already shared with you in the shared folder with efforts, okay? This project, maybe you don't read.
I shared this with the vehicle. I don't know if this is I something graduate.
Okay, so I make now what is this? I already give you the last one that Roberto gave me. Okay, should be this. Oh, let's make it easier. I make. Okay, do you have? No, I make it with chat. Easier. Yes. So now we give you this one copy, so you may have it right now. Easier, of course, for you. Yes, very good. Okay, now I give this to Yuhao, then he will send this very tiny screen. It's terrible. Okay. Very good. Okay. Now he will share this project with you in WeChat. Anyway, I repeat, this should already be present in the shared folder. So many of you will, I hope, will already have the possibility to get it in effort OneDrive shared folder. It's already there, together with manual. So I suggest to you to get inside that folder and see this file, take this to have it on your own PC, okay? If you do not have the permission to go on that shared folder, ask your colleagues. Okay, so by sure, for example, Evie has got all the permission, so she is able to get the. Yes, absolutely, yes. So now I want to show you a little bit what is present inside this project. Almost all the things we have already seen in the previous course of RDE. Okay? So we have the main project, which is this one. Okay? Don't care about we have the configuration, it is the robot. The axis is ER3A model, for example. Okay? Okay, we have the model of the axis group, the fixed axis robot. Then we have some kind of things already set by the project creator. That should be Roberto Romagnoli. So he's the creator of this, and we suggest you not to touch these things. They are already set to be good, okay, in the project and also in the program. So don't take into account what all of these. I know there is a very strong programming style in this program, but this is not what you have to do. It's not a problem. You just have to put it on the flash. Okay? If you do not remember how to do this, just you go here, you take the project, tool, generate the device image. Okay? We saw this the other time. we choose one folder to put all the files, and then the same as I have just done, you take the file from the folder, you put here, and stop. Okay? You don't take care about what's inside, don't worry. It's already good, well done, because the project is already existing. Okay? Then, of course, there is the shell to communicate with system. Okay, now I would like to have it this way. Then we have a panel for input-output to speak with the system and make simulation. Then we have the 3D panel with the robot model. This will be very useful very soon because we will, of course, today we do not have a real robot, we will work thanks to this, to simulate the robot. Okay? And after all, we also have the power set panel that we saw during the RDE lesson. So this is just to see that power set is well working and power is given to the system. Okay? The way we use to communicate is the CPU, which is the black panel, the black round panel you may have seen somewhere either with export guys or downstairs in the showroom, attached to all the robots of new generation of exports, which are controlled by Robox RP1. Okay, all of them, I think, should have the CPU attached, so the user can take the CPU and work on it. This is the real RPL, okay? What we have just seen now is the project made in RDE, as always. Just a project we put in the flash, we put the flash in RP1, we switch on the RP1 and somewhere, somehow in the labyrinth of sockets, and we make it start. And of course we connect. If we have the real robot, it's connected here, the uppercut of the real robot. Today we don't have, so now we will make simulation. Okay? Now, since it is a simulation, I would really like to do again the screen settings to make it a little smaller because I'm not going. Okay, now I try to ping to see the address because I apologize, but I do not remember. No, not this. Very boring. Okay. Let me do something. Let me take out this. Now I need to see again which was the IP address, because unfortunately I could have changed this the other time. Very good. Okay. So, as always, to see the IP address, we go here. It is in FA. Now you don't see, but it is okay. It was the correct one. Okay, if you don't connect, as me now, maybe the problem is that you just do not have the correct connection. In this case, my address is, for example, 10.0.33.1. It's not a problem. You just may have to configure your PC. This is something I teach you now. Because I was looking for the correct address. You see the first. No, maybe you don't see. I apologize for the screen resolution, but it is not important to show you this, but it is, okay? I just made the thing to be able to connect. Instead, the system didn't respond. And we can say, why doesn't respond? The answer is because my address is wrong. Okay? Now, I go here, and I go to the settings, and I should have, okay, here my address should be compatible. Okay, the address of the RP1 is 10.033 something. On my PC I must have 10.033 something else. Otherwise I will not communicate. Maybe the default address for you is very similar. For the RPL it is 10.022. If you do not connect sometimes, maybe for that reason that your PC has not set in this way the communication. Okay, so I repeat, you go here in the settings of Ethernet, you made, I switch it off, so I switch it on again, this one, then to this one, the Ethernet, properties, and you get this. Number 4, oh, what the, okay, so now let's check again because maybe it was, okay, now it is saved. Okay, just this. Now, we would really like to ping. Yes, and we are very good. Now, we can finally make something that you can see, and I switch on the panel. So, as always, I still have some errors. Now we check what. And we say, okay, active emulation active, of course. So, some one of you may see that in the active we do not have the emulation. So, how is it possible that today actives are emulated? Answer, because I already have put inside the flash this file, override.cfg. This file, by default, you see it's red. It's not set in the flash because we expect to connect with the robot. So if you connect to the robot, no problem. This file is not already inside. If you are just like now on your desk, on your office, and there is not the robot and you must simulate, you make right-click, load in flash. I already made this the last time, so this is the reason why it's already inside. Okay? This way, you have this file inside and system makes just a simulation. And understand that actives are not present. Now, we want to enable the panel, the CPU, but of course today we do not have. So, we are again very, very lucky. Because here we have this one. Let me check this. Yes, it's already set in the correct way. Now I switch on RPM. Maybe you do not know RPM so much. If you want to know more, see the video about my lesson of RBT and RPM. Anyway, for you, RPM is just the executor of the panel. Okay, the program which is inside the panel. Just this. Now I don't see these settings, and I want to show this. I would really like to understand what's going on, why graphics is not working. Okay, better. Just need to load. So, let me check. Sorry. Login page. I want to see the alarms again. So, now system is not showing me them. Maybe this one, alarm, yes. Okay, we say active emulation active. It's not an alarm. Emergency stop. Why? Because we are in manual slow. The key is left. Okay? We need to press the dead man on the real CPU. So, here, which is just a simulation, I make this to take out that one, and we have the dead man here. Okay, if it works, now not so much, now I should understand why. Now, let me check what's going on. This stuff not wait, yes, there should be something like this. So, by sure, I look at C0 done. Okay, so, first I thought C0 done, so it's already another problem less we have. Then I have to set something for emulation, you say. Maybe I have already written here. Of course I didn't. Beta, yes. Maybe this. Maybe check this. No? Okay, IMG equal to 1. Yes, very good. Yes. As you can see, Easy is already better than me with RPL. So for any question, of course, hundreds of questions, we will go to Easy. And from Easy to Roberto, I'm sure. Very good, yes. So now you see we have the green light here, and it is good. We have reset the emergency, which is the red push button, okay? Here we do not have again the CPU, so we have to emulate all of this. So at first time, remember this. Input emergency, EMG equal to 1, okay? Set this. Then we can move these 3 ones, which are K left, K right, dead man. Okay? Dead man, as you know, is the push button on the rear of the CPU that you have to hold to allow jog command. Okay? Now I try to move this here to switch on this one. Oh, what a stupid position does it have. Very terrible. Now, for example, I would really like to move. So first login for operator. We make password, very strong password. And I want, for example, to see drive position. And I see very terrible and stupid position. So, I want to try to move the robot in some way. Let's see what happens if I do like this. Oh, it's very bad. Now, let me make, for example, dead man. And you see I have this one. Okay? This one is green, so it's doing something. Now, I want to go, for example, negative with this. Oh, now I don't. It's not happening. Now I move J2. I see I'm lifting the robot. I would really like to understand where it would be correct. Now, for example, let's put, I would really like to have just the normal manual way. I wanted to increase the speed. Oh yes. So we will move faster. So, the buttons you see here are jog commands. The same we have made in the last lesson of RPE, okay? This is jog 1 plus, okay? Jog 1 minus. Now I make it, just to give me a little time that I want to bring the robot to 0, so almost like this. So J1 you see is this joint, okay, moving this way. J2 is this one, the second, so that joint here. Now I make something more clever. J3 is this one. Now I turn the robot. So you see, J2 is almost here, close to the base. J3 is this one. I hope that you all work with robots, so you already know this. J4 is the rotation of the arm, you see, just the rotation. J5 is the wrist up and down. You see the wrist going down, wrist going up. Okay, this one is the 5. Then the 6 is just rotation of the wrist. Okay, so you see 6. Now you don't see very well. I make it better. This way. Now you will see number 6 is just a rotation. Okay, you see this way. The axis, the green axis and the red one, X and Y of the wrist are moving. Okay? You see, this way to move the robot is very easy. You just have the button on the CPU, you just have to control the jog. Then, if you want, you may also make a better jog. Let's say not better, but different. This is related to joint. So, for example, I say this one is joint 1. So, 2, 3, 4, 5, and 6, if you see the numbers, are not moving, just 1. Just J1, which is the motor on the base, and rotates the robot. You see the trace, the red trace, which is circle. Now I wanted to move in Cartesian way. I click this, jog, I make this go to robot, which is the robot Cartesian model. Now I will move in X, Z, Y. Okay? Now you see, robot is moving according to rows. Now, oh yes, I made very bad things. Oh yes, now I should go back. I should reset alarm. Okay, now let me go back. Okay, I went now forbidden position. But you see, robot moves according to rows, X, Y, and Z. Okay, so according to the axis, Cartesian axis. This is the other possibility we have. Then if you have set something related to tool, you click here again, you go to tool, but now I didn't. So, no, yes, now we move to the tool coordinate. So, tool is moving around its X, its Y, its Z. So you see the blue arrow which is here, maybe you don't see it so much, so good, it's the head of the tool. So if I say this to move, now I move according to this system, this reference. Okay? Tool is this one is the green arrow, this green arrow, you see here, is the tool. So now maybe I want to find a way to make you see good. Okay, I make this. We follow that green arrow. Backward, forward. Okay? We just may change the way to move the robot in our Cartesian way. Let's go back to jog, for example. Okay? And now we say, okay, let's do something. How can I say something very easy? Something more I can show you is this command, the grid. We have the grid enabled, and means that the robot will move multiple of 5. This one is I can set how much is the grid. And I say, for me, grid is 5. 5 degrees in this case. So I make joint 1 to move, and now it's 25, 20, you see. Now, if I go back 15, 10, 5, okay, multiples of 5. Then this may be done for all the motors. Okay, also for 2. I say, okay, very nice. I take all the motors. Now, it is a good way, for example, to go to 0 again. Now I would like to go to 0. I don't know how to do. And they say, okay, I use this. For example, for J5, I say, oh, it's minus 50, it's so much. Let me write 50, and I press plus, and just automatically it goes to 0, because minus 50 plus 50 makes 0. Okay? But of course it was just a trick for me. Now the same for axis 6, it was 50 and something more. Very good. Now we put again a clever number like 5. If I move in Cartesian, this is 5 millimeters. I say plus 5, and we move. See the robot coordinates. Now x is 455. I make minus. Oh, I made too much. Yes, now the problem is also figure 8 because it moves a lot. But actually, if I make very slow figure 8, okay, I moved only 5. This is 430. I move back. It's 425. Okay, so I can move both in Cartesian way or in jog thanks to the grid. So only on fixed points, not on real numbers, just fixed. Now we wanted to program because we say RPL is the robot programming language. So now that we know how to use the CPU, we wanted to make one program. So we go here in file, I have some text I have already done, I make new file, yes. Today I say test RPL, today is 2018, 10/16. Okay. And I make a new program. Now I can write. What I want to do this morning, for example, is to make a very easy program. Imagine a pick and place, okay? We just are together with the customer, let's imagine, and the customer says, I have bought an effort robot because I produce these kind of things, and I have to connect the cable, so I have the piece of plastic coming this side, the cable coming this side, the machine makes them together, but someone must take this and bring it here. Who makes this? The robot we have sold to the customer. So we must teach the robot to start the motion, so for example to a 0 position, which is always the same. Then we say, okay, go here, go down, take this, go up. Don't touch the computer, so go up. Go down, leave this. Then go up again. End of the cycle. We do this to the customer, we have finished. Okay? Half a day we made the installation to the customer, job is done. This is very easy. So, what we do today is properly this. Now I will make a program that is not maybe the easiest possible. Let's say I could write everything just in the main. But I wanted to show you some features of RPL today. So I will make something more. Okay? So, for example, let's start from the RPL structure itself. Maybe I want again to make the screen a little bigger, but stupid Windows is always... okay, let's try this. Maybe better, maybe a little better for you guys. Maybe not so much. But okay, we will try. We have here variables. We can set variables. Here we write the code. Here we write the subroutines. And here we may see the log file while executing. So, let's start with something easy. We want to move the robot to home position. Now, we look at the robot, which is here. Very nice. And I say, okay, let's look at the monitor. Robot position are all 0. Very good. So, I say, I go to my program, I go to variables, I go to, for example, routine modules, which are internal to the program. I make edit, of course, otherwise I can do nothing. And I say, no, not routine, module. Module means global, okay, global variables. I just make this little explanation. You know that in programming we may have global variables and local variables. Global variables are the same for all the programs, all the routines, all the functions. Local variables may be just inside one program, one function. I say, I want my pointer to be global. So I put it here, I go in module, and I click this green button, which is the insert. And I say, I want to use module, yes. Name of variable, this is my point home. It is what kind of element? It is a point, and I want, for example, point joint. I can set point joint variable or point Cartesian. You see, it depends on what you have to do. If you are reasoning in a Cartesian way and you have need of something, you use the Cartesian. Like now I say, the composition is 0 joint, I make the joint, of course. Okay? I make this, and I say init value, okay, 0, 0, 0, 0, 0, 0. 6, 0. Okay? 6 axis, 6, 0. Very easy. Description. This is just home 0 point. Just a description I set on my own. Okay? I set this. And we have this point. Okay? The first thing I do here in the code is, first thing I do, of course, is a very nice comment. I double click here. This one is the comment in RPL, okay? Common, movement, other comments. Then now I introduce you some of them. Common, let's make comment, very easy. I go here, value, and I write. Begin of pick and place program. Okay? This is begin, I wrote the stupid Italian way. Begin this way. Very good. Okay, now first thing we can do is to move the robot to home. Now I make here below, I have already suggested some commands. This is memory to make a memory of points. This one and this one are move joint point joint, move joint point Cartesian. Now I explain these two. Move circle, move line, save. So, save is just to save the file. Very easy. Move line is to move in a row way. I have one point, I have a second point. I move directly with a row. This is a move line. Very easy. Move circle is, I have one point, I have the second, I set 1/3 in the middle to make the circumference, to make the circle, okay? From my origin to my target, I have the middle point to make the circle. This is M circle. Then, move joint means make the easier run from the origin to the end, but every joint for itself. I don't care about the robot structure. I just ask every joint, where do you have to go? Some value, just go. So the robot will, for example, do some kind of motion which is not linear, is related to joints, some kind of curve. Imagine my robot is here. I want to move here. I say move line will make the row, the line. I say move joint, the robot will say I only have to move axis 1. So we make a circumference, an arc, because the easiest way is just to move joint 1 and make this. No need to move this one, okay. But in the row, I make the row, I have to bend this, then to make it large. So, geometry is controlling the robot. If I use the linear motion, I will use, now I make you see also on this, because maybe if you are looking at the video, maybe people looking at video, not looking at me, will have no idea of what I say. I go here in the position monitor, and I say, I want to move the robot this way, or let me use very stronger, okay? And I say, I want, not X, I move, oh, very terrible, I do the stupid things. Stop, give me this. I say, I move, jog, tool, user frame, okay? Now I have done the stupid thing to go here, no? So, now I have reached, how can I say, singularity point, because I had joint 5 and joint 6 and joint 4 all together. Okay? Now, I want to make, I still have the grid. Okay, I move it almost to 90. And I say, now for example, I move the robot in this way. You see, it is just rotating. If I want to move linear to the origin, I will make it different. Okay, now, let's make also this little example. Okay, so, the robot is here. I have this position. I go in the program. For the first thing, I say, I don't want to copy and paste all of this. Just move. Okay? And joint PJ. Move joint to current joint position. This position, 50.41 minus 9.24, is this one. You see? System automatically checks current position and says, okay, you wanted to go here. Very easy. Go here. This is the command. Then I say, okay, now I want to move this direction. I make it this way. Then let me, for example, do something different. I go here, then I go here. Okay? Then let me also put number 4 again to a clever value, almost. And they say, now I want to go here. But to make you see the difference, I do the M-line. So, system will move to the first point in joint, to the second in linear. Now I save. Okay? I stop the edit, I restart, and I see the little gray arrow here, which means like the mouse, it's a cursor. Okay, now I set it here. Now I can start. Very easy. Oh, something stupid happened. What happened? Ah, yes, no, I was not in execution mode, stupid me. Restart. I go to K-right, which is not showing me properly. K-right, okay. Motor. Okay, now I start. Now I start. You see, system is going here, and now it's making the linear way to the second. Look at the row stripe. I make it stop. No, stupid. Okay. Look at the row line. Now I make it execute again, and we look from above now. Okay. I make also a little more zoom. Okay. You see this? I make it again. Look at the trajectory of the robot. I make restart. You see the gray arrow again here. Start. For the joint motion, it makes a curve. For the linear motion, of course, I make a line. So it's straight. You see? Two motions are different. The two traces are different. Because one is just the easiest way for the joint itself. The other one is geometrical. I command ET after ET to make all the row, to make a Cartesian straight line. Okay, so different ways. This is what I wanted to show you. Okay? But now we say, okay, we have this one. Now I want to edit again, so I take out this, I edit again, and I say, yes. It's clever to avoid a stupid singularity, I put this to joint 5. Okay? Joint 5 this way, -90. This way, I avoid the singularity of joint 6 and joint 4 aligned. Otherwise, it is the singularity way. Don't worry, we make it this way. So, first thing I want now, yes. Because I want it to be global. Module means global. So all the programs, all the sub-functions will see that point. Actually, it's almost useless because we will use it only once in the main. But user-friendly, yes, they should all be global ones, of course, to be used by all the systems. Now we have no one, so we don't care. But we may test different user frames according to what we should do. Okay? Then, for example, I will make you see something different.
In the module, what you define a point with two homes, instead of going two homes, and read by RPL.
No. RDE is used just for the simulation of the robot today. Actually, this part made from RPL is on the CPU, okay, on the CPU, and I think these variables, I'm not sure of this, but I think they are not shared.
The last time I must define a variable, use the external.
External, yes. I think that it is possible. Now it's something I'm not so thrilled about, but I think yes. We can do what every one of you must do. We take the manual and we say variables, data type, page 6. Page 6. We see a lot of interesting things, and I want to see the difference between the types. Okay, constant retain, okay. Look how much modules public. No, we wanted the external. A lot of interesting stuff. Now I want to see. Now let me make easier. We said it was external. Now I go here and I say, okay. Let's see what is the external. Okay. A variable can also be defined. Let me make it bigger. Okay. A variable can also be defined as external. This type of variable is defined inside the machine program and can be used in all programs and under routine. Okay, let's see global variable. The type and name of this variable is defined inside the machine program. Okay. Va bene. So almost the same. Yes. This type of variable, look at the last line, is used to exchange data between machine program and RPL robotics program. Okay? So this is properly the way you have to do. So if you have easy questions about RPL, take the manual already provided in the group, so you already have. Look for information here. Roberto made a very nice manual, okay? So, look at this, learn this, study this. You will find a lot of answers to your questions in a very good English. So, now we have these point joints. Okay, now I wanted to take, for example, the 6 points. Okay, we said today we make pick and place. So, I don't know, let me move the robot in some way. I make this one and I say, okay, let's move, for example, that direction. Okay? Maybe, yes, this way. And I say, okay, let me see that point. So, I see almost 400. I wanted to save a fixed point now, okay? I say program, I put a new point. This time I want to define it Cartesian way, okay? And I say this point Cartesian is point fixed, for example, or instead, yes, let's say point fixed. And I say this is fixed point, and I set the definition. And I said it was 430, if I remember well, minus this one, then I set one random z like this, then I don't know, maybe I have to put something like this, but now we check, okay, now we check, so yes, almost something like this. I have so much z, now I will, for example, make, yes, okay, I made it good, okay? This is my fixed point. I decided this is the fixed point. Let's now make copy, paste. I defined the place point. The place point will be almost the same, maybe here, maybe a little higher, let's say. Okay? This way. This will be, you see, I made just y coordinate with opposite sign, so not right, but left. We will see in the program. Then, we need, for example, to define an output, because we have the flow of the robot to take the piece. Now, for today, let's make an easy example. We put here, always in module, yes, I wanted to say an input-output. Let's see where it is. Yes, let's say what happens. I want to say output, it is an array which goes from 0 to 7. It should be some way, it should be some kind of system. Bool, yes. Okay. Now, let me check something more. Variable, maybe it is global. Okay, something like this. So I want to make, but I still need, there was the way to make the default. Okay, I made stupid questions. Okay, just I need to use this variable, okay? We define this. I thought now I will be sure of this. Let me be sure, let's save. I should already have this one. Let me just load this one to make comparison. And I say, okay, I should have made it in this way. Okay, sorry. It is the external, so I take this out. I erase this. In the external, I can put some kind of predefined variables. Okay? I just write output in the external. Output is a system word. Okay? When I write output, system understands what I want. I want to set the RP bool output. The first output are set on our RP1. Okay? For example, now, let me make something very easy. I make an assignment. I look at my variables, I say output of index, for example, 5 equal to true. Okay? You see here below we have true and false. Very easy. Now, we execute again the same program of before. I want to like save, then I go this way, motors, and I go. I didn't set power, I always set motor, start. Now we move to that position, the same before. Now we move back. That position. And now you can see on the RP1 output 5 is enabled. For all the people not looking at me directly but looking at the system, you can see the pan.io in which output 5 is set to 1. Okay? So, the system can directly make the handle of this. You just connect one wire to this, the wire to the actuator of the claw goes here, we will take, we will move, we will leave. So, what we can do is to make a function to do this. Very easy. Of course, after we give the command, the claw is not immediate. It is some time to take the piece, okay? I cannot say command and move, otherwise I move and I'm still closing. I need to say close and wait one time, then I move. Otherwise I say I move suddenly, I didn't close. Okay? Do you understand? So, now, let's make, for example, subroutines. Here we define subroutines. Now I stop everything, I say, okay, no more this one, and I say, let's write a new subroutine. Okay, let's make close. And let's make another flow open. Okay? In here, I can choose the code of which routine to write. Okay? If I go here, this is the main. I want to write the close command. Okay? So, here I say, for example, let's make a little comment. This is flow closing function. And okay. Then I say, okay, I want to say this output 5. No, let's make something more. Wait. I go to main. I use this one to insert a new line. And here I want to use alias. Alias is this other command which makes a refer between one name I choose, okay, I make a new, for example, this is flow, new, and I say, okay, I want to make this flow, which is module, this is boolean, this is flow variable, so command, floating the variable. Okay. And I say, I want the flow to be referred to output 5. Okay, you understand? This way, if maybe the customer says, no, don't use output 5, I have already used it for other things. Change it. Give me number 4. I don't have to go inside the program and look for all of them. I just go here and say, okay, you do not want number 5. Okay, I change. Number 6. And then we always just use the flow, the name flow. Okay, I go in the flow clause and I say, very good. I say common set equal, okay, flow set true. And I give the order. Like a list, yes, it's like the list reg, the list const we make for RDE. The same. We give a name to a variable. Then we wait. To wait we use another command which is dwell. It is the same as RDE. If you have seen in R3 language, we have the same. Dwell means wait a little time. And we say, I don't know, just half a second. Wait half a second, the flow is taking the piece. Okay? I make this. I have finished my subroutine. I do nothing more. I go to flow open, and I do something similar. So, this is flow open function. Here, the text flow equal to false, you see here, false, okay? And then, again, we need to wait the flow to open. Okay, so other, dwell, time, 0.5. 0.5. Very easy, okay? So, this is flow close, this is flow open, this is the name. Now, we take out these ones. Very bad. Control Z is not working, okay, I just wanted to do something different. Okay, who cares? I take out these, I say, for example, first time, we want to make the pick and place, okay? First, we move to the home position. At the first time we switch on machine in the morning, machine goes to home. So we say, okay, just move joint, and here we may set a lot of things. Move joint, position home, okay. Speed may be set according to these already predefined variables. These should be speed in millimeters per second or something like this, but again, constant task speed. I take this, for example, 300. Zone is the joint radius for the next move. Imagine I give the robot two moves different. So I set from point 1 to point 2 to point 3. My question is, when the robot arrives to point 2, do I have to reach that point and stop, or can I just arrive close and then make a smooth, a bend, and start already moving to number 3? If so, I can set how much is the distance to make not the corner but the curve, the radius. Okay? Otherwise, if I wanted to say, no, I want to go precisely to that point and then to the other, I set the fine. Fine means go to that point directly. Otherwise, I set the millimeters of the radius. I say, yes, I don't care. I say, no, this is precise motion. I want to go fine. Tool. I have, okay, I never inserted tool. Yes. Very good. No one. Fine is Z0. They are the same. Fine is just a name we set to the, tool. Okay. We set very clever easy. See this. Z0. 0 millimeters. What is a circle of radius 0 millimeters? Single point. This means we want to move fine to the point itself and then to move out. So use fine or use Z0, the same, up to you. fine is just a name, again a label we use to know I want the fine movement which is perfect to the point. Otherwise I say, okay, I arrived almost, I make the radius and I join to the next motion and I move. For this we move fine. Okay? Then we start our pick and place. So let me put a little comment, because I love to write comments, and I say start of pick and place. Okay? So, here, first thing is to move to pick point. But maybe we cannot go directly. We have to move up to another pick, then to go to pick, then take, then maybe up again, move, drop. Okay? To do this, we just use offset. Okay? I say, what is the overpick point? It's the same as the pick point, just taller, just higher. Okay? The pick point is set. I just want to tell the system, go to this, but before, go to the overpick. The same but higher. Imagine there is the obstacle. Okay, I did something very wrong. Imagine there is an obstacle. I cannot say the robot go directly here, otherwise I make crash. I have to say go here, then go here. Okay? The first point is the same as it is, but higher. If one point is easy referred to another, in RPL is direct to make this, to write this. Now I make it see. We make a routine point, for example, because I'm sick and tired of main point. This is the T over pick. T over pick is just Cartesian point. But I don't tell you how much. I do not put initialization. I also make copy, paste, and I make the overplace. Overplace. I don't write the numbers. I don't know. Okay? But what I know is how much I want the height. So, I set one real variable. Okay? One real variable. It is the height high above. Okay? How much has the height above to be? How much? I set this. And I said, okay, let me set some value, 150 millimeters. Okay? I say, before going to point, be that height higher than 150 millimeters, even more 200, okay? 20 centimeters or something like this. Okay? Go above, then go down. So, what is the way we have to create the overpick? I go here, let me do copy and paste. Before the start, I make init. Init. Okay? Inside this initial part, I say, okay, I set equal. My destination is the point over pick, and the expression I make offset. So, the overpick is an offset taken to another point. The point is the pick point. Okay, so the overpick, I will say, is the offset of the pick in 0x, 0y, and Z, how much? Yes, as above. Okay, if I want to change this value, I can. Also during the program, because it's not a constant. I never, if I go here and I say constant, I say it is 200 forever. I say, no, it's variable. I at first write it is 200. Then, during the program, we can change. Okay? We will see. So, I create the overpick point in this way. I take the peak point, I make it higher than edge above. I save this. This is overpick. I have created the second point. This is just geometry, okay? Now I copy and paste. And I make the same for the other place, thanks to the key place. Very direct. Okay? Now, that we can place a routine. How much is this? And we say, okay, let's, for example, make motion. I want to move. First motion, let's make. I don't care. Move joint. Move joint to the overpitch. Speed is 200. Zone. This time I will go here and then down, so I don't need to define. Just to set my... again, I don't know how much I wanted to do the radius. What can I do? A variable. Okay? I go here, I make, give me a variable, which is joint radius. This is real number. I don't set this. In the init, I set this. And I said, okay, let me set the joint. Where the hell joint radius? I say it is, no, sorry. Of course, to be this one cannot be real. It is zone. It's the same, but the system makes them different. Okay? So zone. Okay. And here I said, okay. I make joint radius, and now I can choose. I say, okay, for example, give me just 2 centimeters of radius. Too few, yes, 40. Okay? I say, the joint radius is this one. So, when here I make the movement, and I say, move joint, P over 6, speed, I don't care, let's say 200. Zone, joint radius. Tool, yes, tool 0. Don't care. Okay? So, this motion will be joined to the next, so will not reach the overpick point directly with a corner. We'll make a bend. And the radius of this circle is joint radius, which we set is 40 millimeters. Okay? Just this. If runtime we change, and I will show you, we can change and see what happens in the program. We can test. Then we move to the peak point. Could we do this with joint motion? No. We must go direct down. We cannot expect maybe to have some strange curve, because I need to take one piece, I need to go perfectly vertical on the piece. Imagine I'm moving in some stupid way, I can do something like this and hit the product. I am in the overpeak, vertical, I must go down vertical, take the product. Vertical. So, linear. Is it clear? This is very important. Linear, point peak. Now, I make you see the movie. Don't panic. I have a movie of a very nice pick and play. I always show this a lot. Oh, yes. This is a very beautiful example I made for one demo. Don't care. This is the robot we use today, the RPL. The game is the Tower of Hanoi. You know? We have the tower. No, sound is not necessary, it's just air. This is mainly the same issue. We do a pick and place of things. We cannot, you see, when we go to take a piece, we move vertical. Because after we can make some kind of very nice joint, you see. Okay, when it is moving up, it's moving bend, not corners, otherwise it would be very slow. But when I move in a vertical way, to take or to leave pieces, I must be very precise, very vertical. Now, this very nice robot is making the tower, thanks to a series of pick and place moves, you see, just them repeated a long time, thanks to the solution algorithm I wrote myself, and so now we will see the Robox Tower of Hanoi completed. Okay? You see, now this, now R to the right, now letter O, now letter R. You see? Pick and place is done vertical in the two movements of vertical pick and vertical place. So linear. This means linear. So I go to the pick point with some kind of speed in defined way, because I must to be precise to the pick point. And okay, always this tool, I don't care. Then here I close the close. So I make common function. It should be now, so it's here, call. Call the subroutine. Close. Very easy. I already wrote this routine. I go here, close. In here, I make the close command to true. I wait a little time to take the element, then I will move away. How do we move away? In the same way of this. We make copy, paste, we move linear vertically, backwards to the overpick point, then copy, paste, not fine. Now again we can make some joint radius, because vertical, we can make the joint. Then we move to the over. Copy, paste, the over, place. Then copy and paste, but this time we take this one, because we move fine to the place point. Here. Okay? Then, now we reach the place point, what we do? Now we call to open the claw. Okay? Now, claw is open, I go back to other place. Okay? And now, almost we have finished. Correct? Let's try. Okay, let's see what happens. First information for the init here is just be sure to open the claw. Just at first. Imagine the system already starts with claw closed, goes to the product, problem, the claw must be open at first. So okay, in the init here, I make a call of claw open just at first, because in the init I say, okay, I open because I need to go and see. I save, I go K right, which is the automatic mode, I enable motor, I set restart, so gray arrow here, motor, green, yes, I want this, yes, very beautiful, now I start, system is moving, let me give a little more feed rate. Okay, more feed rate, yes. That's it. Okay? I do it again. I make a restart. Okay? Even more speed. I say start. Home position. Take. Go here. If you see, for example, now I say, I was using number 5, then I switched to number 4. I don't want to. So, I take this out, I go to edit, I go again to the alias, I say no, this must be number 5. Value. Because I already have this, I like this. Okay? Then, for example, I made the point different, I don't want. I want this to become the same, just because I want to modify, okay? Then I say, okay, save, go out from here, right, motor, restart, go. Look, I had the output 5 still 1. Now, the output, no, of course if I don't switch on I will never see this. We go down, we close the claw, you see output 5 now is red, we go up, then I increase the terrible feed rate, we go here, we go down, we switch on, and we go up. So, if I make you see, I want, let's make for example, let's point strip, I put more points, just some more points, okay? Just to see a longer queue of points. Now, let's see. This one out. I make it again, so I want to make you see the difference of the motion. This one is joint, so as happens. Now, okay, see this one. You see the bend from the peak linear to the over peak, there is the bend to directly connect to the motion. Then here you don't see, but it is again this, and then in this one. But now we see, okay, the customer is almost happy. Robot is doing what we want. Good. But we would really like this to be automatic. And you repeat, and you repeat, and you repeat. Okay? How could we do this? Making it in a circle. The way to do so is to go here, to the start, and set a label. Which is label. I have no one, I make a new. This is loop, for example. Do you want to define a new label loop? Yes. I say, I just write here a label. This label is the loop. Then here, I make a go to loop. Each time I reach here, I go back to this. You understand? The difference, main difference in programming between RPL and RPE from one side, let's say just RPL and R3 programming is that RPL is a one-shot request. I tell the system move joint once and system will move. In R3, when I write a rule, I must keep doing the command every rule sample. Okay, if I have a move to command in the rule of R3, I must always say move to, move to, move to, move to. Every time until I have some kind of condition and I can go out. To keep going. In RPL, it's just a list of commands. I see the list, I finish, I wait them to be executed. Very easy. Okay? But, so this is just for the people of you who also write R3. Now I make save, and I want to show you this new behavior. Restart. Start. Now, system, see the cursor. It's here, it's here, it's here, Now making the function, go to loop, and again, the system is making again the pick and place. Looks at the output file, which is our flow, either on the RP1 if you want, or here you see now flow is off, now flow is on. Do you see? This is something that is very useful. So, a little interesting part. D05 is the system name of this variable. I do something more. I go here in the panel. I teach you something. We modify a little the panel. We put a cube. Okay? Very nice cube. I want it to be this way. Okay? Just tinier. No, this one was nice. Give me this. Give me this. Okay, let's make it even 50. Okay? And I say, position is arag dot QC1. Okay, I have to have written it in the correct way. Let's see. Okay. Now, I have this one. I just put a block on it. But, I want it to be visible only according to this variable. This is a little interesting feature of RDE. Every tile may be visible or invisible. If D005 is true, this is visible. If it is false, it will be invisible. Now see what happens. This is the way we can simulate the product. You see? We took the product, we bring it here, we leave the product. Now we understand the flow, how it works. When there is the product, the flow is closed. When the flow opens, the product goes out. You see? The system is making the pick and place you want. Now the customer says, yes, good, but please, because customer always makes a silly question, please make the robot make, how can I say, a bigger bend here, okay? So, we make a watch to variable. I set line watch, and they say, oh, don't reduce. Yes, interesting. I would really like, for example, to change something. Now, for example, I'd like to stop. I say to stop. Okay. We stop, the system is in pause. I go here, and I say, yes, but I want, there should be some kind of this one, to set this one, and I said, no, I just wanted to write something, maybe not so direct. I can say, Z40, okay, Z100, okay? Then I say, now I know I'm here, moving to this, okay? And I say, no, set to PC, I directly jump to this, okay? Then I say, step. Here you see it's written continuous, so system works continuous. I press step. Step means every start, I just move one instruction. Start. Oh, yes, I don't have to edit. Start. I made this. Now, if you see, the value is 100. I just activated this. Then I say, okay, I was doing this. Go back to here. If I do set, I do start, sorry. I do this, and I wait. Go to loop, do. Label, do. Go, do. Okay? Now, with this way it's good to debug, to make things one by one. Okay? This way, this way, this way, to see what happens in the program. If you have problems, you use this way to check. Then I say, okay, don't care. Just keep step over, just continue, go. Now see. The radius is very bigger now, you see. Before it was tinier, now it's very large radius. Now we say, okay, in the same way, I want the height to be bigger. I want to make it go up. The robot is bigger than this. It can go up, it can move a lot more. Okay, let's stop. Stop. I remember it's step 11. Okay, I always have to use these features very wisely. Okay, so I remember I was doing this. Okay, I said, I want to see, for example, some kind of variable. Here, no subroutines, but this one. Head above. There should be some way to set this value. No, it's not possible. I say, okay, I don't care. So, I go here in the init. Better. Oh yes. I go out from here. Now, illegal state. Yes, I know, it's illegal state. Now, I go to edit. Oh yes, terminate, restart. I made very bad things. And here I say, okay, I just wanted to assign. Page above, we say, initial value was 200, yes, okay, I test here this, so I take out from here. No, I don't want this. No value. Don't care. Okay? I set this in the init. And you say, okay, it's almost the same. Not the same, because now we can change it to runtime. The same as we did before. Okay, so I go here, I make motor, I make restart, I start. Now I give a stronger feed rate, as always, yes, 100. Take the piece, we move. And then I was saying, yes, okay, but I want to go up. So, stop. I didn't want to stop here, so I take again the step. I do one step, and then I say, oh, this one. Let me change this. Let me say, not 200. I want more. Now I want 300. Okay. Now, set to this step. I do that step. Okay, I take out the edit. Step. Now you see it's 300. The line watch tells us the values. Now I did the peak. So I was here. Okay. I say, okay, set again here. Take out this step in, step over, continue. Just go. And you see? No. Oh, no, sorry. Stop. I needed to make again the offset. Because I changed the edge above, but I didn't change this. So, set PC, I make step, I do this, now they changed. Okay? Now, I was going again here, set, I take out the set control, and I can go again. I take out this one too, which is useless, and I go. Go. Now, of course, you will see, now it's higher. than before. You see? We can do all of these times to refine the program online. We never have like RD to switch off and reboot the machine. We just change some values, some parameters. Okay? If variables are external and so shared with RD, you can also make with thanks to the shell. But while you ask the customer, you do not have the shell, maybe. You just have the CPU. And so you use this way. Okay? So, oh yes, by sure. So, more than break. Guys, this is mainly what I wanted to show you today. The idea is this program, okay? It is an example. Now, I just, before the break, that of course a very nice cup of coffee will be necessary, I just want to show you how to save the program, which is very easy. Now we stop, we let it finish, and never let the robot with the product in the cloud. Okay, I stop. Stop here, okay? I take out this, and I say, File. The program is automatically saved when you go out from edit, but sometimes you click Save, which is better. Then, on the CPU, you can put a USB pen. There is the little rubber part. You put this, I go here, I say, test RPL, USB, to USB, one is uncopied. Now that I'm simulating, I do not have the USB, so I have one offline folder, which is this one. I just show you this. Here in the RPM2, I have this external device, .cfg. I open this file and I just write where I have to put the file. If I am online, I use it point, which is USB. But now it's commented and I have C RPL because I wanted so. Okay? So, I just take this and I say, very good. C, RPL. And here I have test RPL 2018 1016. Time 1040. Yes. I just saved the program. Of course the program is XPL format, which is not very beautiful to be read in this way. Okay? It's not possible to do this. There will be maybe in the future an offline editor of RPL. Up to now, you take this and you put in the CPU. If you don't have, you put in the CPU emulator, which is this one. Okay, you go here, you load the program, you take this. Okay, just this. Now I suggest you to have break. Now I show you this little last part, which is just a little explanation. This document is also available on the shared folder of OneDrive of effort. So again, you should take from it on ask to have it, otherwise I will send you now with the other material. So, this is about interrupt, okay? Because we have seen that RPL makes program in the way that they are a list of command the system reads just once and executes. But so, for that reason, it may be very interesting to have some kind of interrupt, to be able to do something very hard real-time related to some kind of input. Some kind of condition may create some kind of different things. Okay? So, the way is to use the interrupt. So, let's add an integer variable. Int r, which is the interrupt variable. We can, now I don't want to use, I have already saved. I can, for example, go here in variables and put one new kind of interrupt, okay? This is the variable, int r, to make int one. Okay? And we declare this variable. Then we check again the manual and we say, so we should create a subroutine that will be executed by the interrupt. So for example, we go here in the subroutine and we make interrupt. Okay? This is some kind of routine. And this way we go inside and we say this one is the interrupt routine. Okay? And here you will write what to do. Okay? So, something, some kind of comment, some kind of maybe jump to some label, some kind of what you need to do inside the interrupt. So this is up to you. Then you need to make it happen. And so we say this command, interrupt set, is joining the variable and the function. So let's imagine that this variable, this variable is the interrupt handler, like just a flag to enable, okay? So we go in the code, in the init part, and we say, okay, give me the intercept, which should be intercept, and I say, okay, this is my interrupt variable, I want the execute interrupt. This command makes just the connection. Says, when this variable of interrupt is engaged, we suddenly call this function as interrupt of everything else. If the program is executing the motion, I do the interrupt and I make this. Okay? So, then I may have to do the condition. To do the condition, we have this function, interrupt condition, or there is also some interrupt number, okay, if it is related to some kind of error, okay? But I very prefer the condition, and we say the variable is always this one, okay? And then here I write some kind of expression. When this expression is verified, I engage the interrupt. This is the condition. You may set, for example, another variable that you may control. How can I say? If, imagine you have one variable for the piece. Okay, imagine we have taken the piece in our program and we are moving. Then at a certain time we drop the piece. The claw fails and the piece drops. Imagine we have some kind of sensor in the claw to understand this. Okay, we have the sensor, so we make some kind of external, we take the input, which is again the RPL input, and we say, okay, now I make one module variable, which is fallen piece. Fallen piece is a bool. And they say, okay. And in the code, again, I copy and paste, and I make the fallen piece is some kind of input. Okay? I say, now today we cannot test this, I do not have the way, but I set this is input number 6. Okay? Then I say, This variable is always false, okay? When the flow takes this, the system detects this, and this is false. Then maybe I lose the piece, and the variable becomes true. So when I make the interrupt condition, here I say if fallen piece is equal to true. This is the condition. When fallen piece is true, I engage the interrupt. Okay? And it is just to set this. I write it here, it is, you see, an initialization of the interrupt. We never have inside the code if fallen piece equal to true, then make the interrupt. Because the interrupt is always, it's not in a fixed part of program. At any time may happen this. Then we enable and disable the interrupt. Of course you say, after I have taken the piece, I move to the place area. I leave the piece. Doesn't my sensor maybe make a false reading? The false of the fallen piece? Hey, I see nothing. The piece is fallen. No, it's not fallen. I open the close. This is why the piece is not present. So I can enable and disable the interrupt. Inside some pieces of program, I can say, now I engage, now I disengage the system. Okay? For example, a fallen piece is after I close the close, I must engage the interrupt. Keep this. When I go and I leave, I say, okay, now no more. I don't care. Okay? So only some parts of the program, if you want, can be controlled by the interrupt condition. Some other part, I disable the interrupt. I say, I don't want to use it. Okay? So, the close closes, and here I set, okay, interrupt enable. And I set again this one. So, after I close the flow, I start to say, okay, take into account if I lose the piece. Not before. It was empty. Then, here, when I have to open the flow, instead, here I say now, interrupt disable. Again this. I have arrived to the end, I say, okay, no more. Now the piece is arrived, I open, of course I will see no piece. If I open, it's not an error, it's something I want. Okay? So, interrupt disable, interrupt enable means only during this motion, these three elements, I will have the interrupt controlling them. If I lose the piece when I am moving, so to the other piece, to the other place, and sometimes I lose the product, I will engage the interrupt. Is it clear, the idea? Yes? Okay? So this is the way. Then I go in the subroutine of the execute interrupt and I will write something. If I lose the piece, I can make some kind of, I don't know, let's see, I can jump to an error state, for example. What can I say? I can start to stop, start, joint, lots of things. Here I can have some kind of error command. Let me check in here. I'm not so skilled in using the error. 17, okay. Error. Yes. Set the expression value as error code. Okay. We can say this alarm. Okay? I say, okay, if I have this, I have error, I see, number, string, number again, in which I see error code, okay, some things, so I just write the same, I say value 1, this one is value 10, Okay, today I don't care. Here, I say value, and they say this has pollen. Oh. Yes. No. No. Terrible. Stupid. No. This is str error. And they say, okay, no. str error is a string. Constant. Init value is has pollen. Okay? Okay. I make the error. Then what I could do is to stop motion. I think that stop move is good expression. Let's see the stop move again. I do not remember how to use this, and me stupid. Stop move. Okay. Okay. No. Maybe instead of this, which is just a pause, I will go to another variable in the main. Okay? I go in main, or that, yes, I can say something here, or code main, here I can set another label, and I set end, this is finish. Okay, I set this, then I set, okay, if I have the error, I go to, oh, of course it's local, so I really wanted to do so. So no, nothing, I just needed to do something different. What is it? I can take this out. If I have this in the execute interrupt, who knows? I can make movement, some kind of yes, and yes. I can put something to say stop motion.
Why?
Why? What?
Maybe why? Always keep it there.
Yes, but I don't want to do something so strong. I can set some kind of error somewhere, but yes, for now just to make something easy. You have said I make while true, and I just stay here. Oh, and do you want to do it? Yeah. I copy, I paste. Okay? Just something like this. I say interrupt forever this one. I'm not sure it is very nice thing, but okay. Okay, I get the error, I stay here forever. I repeat, maybe it's not so nice, but it is an example of what it could happen. But what it is important is in the main to set this part, to set the interrupt according and handle the function, to set the function. Then the condition to engage the interrupt, and then you set enable and disable to have the interrupt engaged only in this part of the code. Okay? This is what I wanted to explain mainly. Is it almost clear, this kind of handling? I hope. Then again, you see here we have little example made by Roberto, very good. Ah, yes. Wait for condition, yes. Yes, almost he made something like this. So, you can see this document, which should be again in the shared folder. If you do not have access to the shared folder, maybe I will share now with you this little PDF. Okay? Questions about this? Or RPL in general? No? Almost it was everything I wanted to teach you today. So, if you understood everything, I hope so. We can just see if the system is still moving. Restart. Start. Move as always. Very nice. Feed rate high. And we make it work again. Okay? If you want to try, for example, in somehow to check what happens to the input 6, you may just take a wire and connect this to the input 6, maybe try to make the system to have the problem, okay, to engage the interrupt. Now I do not suggest this to you, just I want to show you the behavior of a working program. Mainly with RPL we make this kind of very easy program for easy applications for customers. Then deeper ones are made by the team of Mortensen and Federico, who will be here soon, I don't know, maybe next month. So they will make deeper applications, because you see, here you may have, you have a lot of interesting stuff. Program file monitor, where the hell is that? Here, okay. You see you have a lot. For example, the punching machine, okay. You see, oh, of course I have not the license. I'm a bad person. We have tracking for the happiness of Phoebe. We have a lot of things, okay, here. We have a lot of already developed things that may be used and that will be used while installation of our robots to customers. Okay? So these are more specific parts that I suggest to you to learn, but just asking to people already skilled in this. They are special applications made okay, for special purposes, tracking some punch machine, some other for vision is in developing something like this. Mainly, you just have to write your own program, execute this, see the robot moving. Okay? Is this clear? Okay, guys. So, if you have questions, tell me. Otherwise, course is over. So, feel free to go back to your job, to your office, to your life. Okay? I stop.